All right, guys, so today you're going to need your science journal and something to write with. Science journal, something to write with. I'll give you 1 minute to gather that. I see some of us are already ready. We're already prepared. Some of us are finding our journal and a pencil or pen. Oh, we got a few friends just joining. All right, if you have just joined us, we are getting our science journals and something to write with. All right, we're gonna watch a video first. And just like the other days, while you're watching this video, I want you can jot down what you notice and what you wonder about this video. Okay, thumbs up if you're ready. All right, let me share my screen. There we go.
Wasting your breath.
That is the coolest.
All right, what do you guys notice and what do you wonder about that video? Raise your hand. There's a lot going on there. Peyton.
I kind of noticed that they had like light sticks that were like they were grabbing them and then like pulling them around their bodies and then grabbing them back, like electrical sticks.
Yeah. Let's see, Henry.
They used light energy.
They did. Kaya.
So I was thinking that it was just an optical illusion. That's it.
Okay.
Because, so, you know how they were like twisting up the lasers?
Mm-hmm.
And first of all, I know they were lasers because I looked at the title. And secondly, have you ever touched a laser before?
Have I ever touched one? No.
So if you go to like laser tag, there are some of these lasers that like, it's like a beam.
Mm-hmm.
If you touch it, nothing will happen because it's pretty much just kind of colored electricity, right? Mm-hmm. That doesn't have a very high like shock rate. So basically that optical illusion is because nobody can twist up lasers. They probably have extra people up there that are like taking separate lasers and like putting them out so it looks like they're twisting them, while in real life they're just miming it.
Interesting thought. Thanks for sharing. Sia?
So I noticed that there was one of the states of matter, and I wonder if there were LED lights.
Okay, interesting thoughts. Soften.
No, I was about to ask, but Kaya basically answered it.
Okay. Are there any other I noticed or I wonders from the video? Graham?
I noticed that it was just like light, and it was light energy.
Mhm. Yeah, so today we are going to be talking about light energy. So in your journal, your title for today will be light energy. And we're going to take just a few notes on light energy. Well, there we go. Great thing. Okay. Oh, not the pen. All right. So our title is light energy. Okay. Oops. Whoops. Hold on. Hold on. I don't know what I did. Okay. That's what I wanted to do. All right. So light energy, we're going to talk about some properties first. So it is a form of electromagnetic radiation. Okay, light energy travels in waves. Does anyone remember the other form of energy that also travels in waves? Sanaya, what form of energy travels in waves? What other form?
Sound energy.
Yeah, so just like sound energy, light energy travels in waves. The difference with light energy is that it travels very fast. I'm going to give you a fun fact. So light waves can travel at up to, which means it can be slower, but it can go all the way up to 300,000 kilometers per second. So that's about 150,000 miles per second. That's how fast light can travel.
That's where Einstein's light theory comes in.
Yes.
The E equals mc squared thingy, right?
That's for energy, but yes, light energy is
Yeah.
part of that. Mhm.
He's the one who thought, like, isn't he also the one who thought, like, if you're in a speeding rocket ship, you're going to be much older than the people that are actually on Earth?
Mhm.
I never really
That's how you
understood
can time travel.
Oh, because technically you're going really fast, right? So you're kind of speeding up the time process, which is time travel.
That's the theory of it, yes.
God, that's cool. I want to be in a speeding rocket ship. Although I
No,
don't wanna
not
get
not
old.
the speed, but the time in space is different from the time on Earth.
Yes.
Which is basically like whenever we're in space, we're a certain age. When we blast back down on Earth, everybody's like a year or so older.
Mhm.
And you're
Okay.
just like 3 months.
Mhm. Okay, so light energy is used by plants to produce food. Does anyone know what that process is called?
It's called photosynthesis. No. Yes. Okay.
It is called photosynthesis. So that root word photo,
Also,
or I'm sorry, hold on, Kaya. The prefix photo means light, and then synthesis is putting things together. So they're using the light to put things together to create sugars to grow from.
doesn't the root sim or so photo means light in like Greek, correct?
Yes, it does mean light.
Okay, yeah. So then, I take another language arts class, and they say that sin or sim means like SYM or SYN means like together,
Mm-hmm.
and then thesis means like produce or something.
Yeah.
So like using light to produce.
Yes, exactly. All right, light, unlike sound, light can travel through empty space, which is why we can see stars and the sun. All right, it can travel in straight lines that are called rays. I just slid it up a tiny bit. And similar to sound, because they both travel in waves, these light waves, they can be reflected. Which means they can bounce back at you. They can be absorbed. So if you shine a light into most solid objects, that solid object will absorb the light. Or it can pass through objects. Oops, I spelled that wrong. So if you take a flashlight, let me turn my flashlight on. And if I hold up a newspaper, you can see, you guys see that light shining through that I'm moving? So it can pass through a newspaper, but if I were to get a book, you can't see that same flashlight through that book. So that's where the book is absorbing the light, where the newspaper allowed the light to go through.
By the way, was that a Texas history book?
Yes, it was.
Knew it.
It was American Indian book. All right, and light can also be refracted. And I believe on one of the videos that you'll watch today, you'll see that. So if you've ever taken a straw or had a glass of water and put a straw in it, or even a spoon or anything into a glass of water where some of it is sticking out of the water, if you look at eye level at that, it will look like the straw's here in the water and then the other end is outside of it. I can draw a picture of that. That might be better.
It looks like the straw is twisted.
Yeah, so if I have a straw here, let me do this. So if I put a straw in water, Okay, it'll look like this when it's out of the water, and then in the water, it's gonna be like this. And that's a good example of what you would see. So it kind of looks awkward. It's like, well, how is it bent? How does it look like that? And that's what we call refraction, because the light causes that to bend. It bends what you see. Got one more little interesting fact I'm going to add. Have you guys ever seen a glowworm or a lightning bug? I see some have, some haven't. So they actually create or produce their own light using a process called bioluminescence.
Bioluminescence is like a living thing making its own light using bacteria, right?
Yes.
That's how an anglerfish gets the light on its lure.
The light that goes over their head? Yeah, exactly. Okay, our last thing we're going to add are some examples. I have 5 examples, and then I will take a few from you guys as well. Well, if I can spell today. All right, so objects that are hot will give off light energy. So if you think about the burners on a stove, when you turn the stove on, they will light up in a red color. That if you have an electric stove, they'll light up red, saying that they're hot. If you have a gas stove, you'll see the flame. In a oven, you have coils that turn red.
In a microwave, you have radiation coming down.
Yeah.
Basically, a microwave is technically just a small heated plate.
Arishi?
I have a question. So why do all these objects that get heated up, why do they always turn red?
Why do they turn red? Because, let me explain this. The way that works is, you know, your rainbow, where you have red, orange, yellow, blue, violet, and then like indigo. No, I did that backwards. Indigo and then violet, right?
You forgot green.
Oh my goodness. Roy G.
Big. Is indigo really part of the thing, though? Oh, really? Because
Indigo is kind of like a navy blue color. It's like
I consider it as like a blue purple.
Yeah, that's what it is. So you see my rainbow that I have here? So on our rainbow, the hottest colors are towards the bottom. So this end is the hottest. And up here at the red, this is the coolest. So that doesn't mean red is cold. It just means it is colder than a blue or a purple flame.
That's why blue files are the hottest files.
If you've ever seen, it's really, in a campfire you can see it, but it's better if you've seen like a gas stove, like that flame that comes up, you'll see the blue light closest to where that flame comes out. And as it goes up, it goes from blue, yellow, and you might see some red at the tips. If you look at a fire, if you look really close at like a campfire, it's kind of a bright yellow. And then as those flames come higher, they turn orange and then red. Sia?
For the rainbow, is the top coolest because it's like higher and because space is like colder and it's more towards the space part?
It has more to do with how the light is refracted with the sun and the water on the earth. And that's where the cooler air is going to have the red color and the hotter air will have that purple color. So close,
Okay.
close, yeah. Okay, other things that are examples of light are going to be, stars in the sky.
How about the sun?
The sun is also, it is a star. So that is one of my examples. Okay. We have lasers like we saw in that video. And then anything that has a light bulb. Will also be an example of light energy.
What about something that makes its own light? Like, it doesn't, but it does. What about like glow in the dark things? Glitter.
So yeah, those have, well, glitter is reflecting the light from the.
Yes, so technically not really, but
Yeah.
the
glow sticks, I'm not
yeah, glow in the
100%
dark. Wouldn't that?
sure. I'm not 100% sure about glow in the dark items or like you're talking about the glow sticks. It has to do with the material that's inside those glow sticks. So we would have to do some research to find out what's inside. And then whatever that material is would tell us why it glows.
But
If you notice on glow sticks, you have to break them for them to work. So if they're not broken, they don't shine light. So think about your house. What are some objects in your house that have light energy? Raise your hand if you have one. Sanaya.
A lamp.
Mm-hmm. A lamp works. Graham?
Like there's a light right here.
Mm-hmm. So like is it above you?
Yeah.
Yeah. Okay. So like a ceiling light. Peyton?
Candle.
Mm-hmm. Oh, and a candle is a good one to look at to see the different colors too. Sia?
I have a camera, and when you take a photo, it like flashes.
Yeah, so a camera flash. Arushi, do you have one? No? Okay, I thought your hand was up. All right, guys, so today, that's all the notes we're taking. And today, you guys are going to do a couple of things. You're going to get to go into vocabulary. And I assigned a couple of activities in there for you guys to complete. Have you guys used vocabulary with assignments yet? I see some nodding. So if you go in through class link, it logs you in and you will see a video on light. And I believe I have the video. There's a vocabulary game to play. And there might be some questions on there just to kind of test your knowledge of light energy. And let me go back here. There is, all right. There will also be, oh, my computer's going super slow. Okay, there's also a Discovery Education video about electromagnetic energy. And, oh, am I not sharing? There we go. Can y'all see that now? Okay, sorry, sometimes I forget to, oh, I paused it, there we go. All right, so there's, in class link and vocabulary, there's some assignments or activities for you. Then there's an electromagnetic video. We said that light energy is a form of electromagnetic radiation. Those are a lot of big fancy science words. That video will explain in a little bit more detail for you. Okay. Then that's all in your Learn folder. In your Create folder, you get to create shadow puppets. So you're going to use your knowledge of light to create shadow puppets. Do you guys know what a shadow puppet is? I see yes, I see some no's, and I see just some blank stares. So a shadow puppet is when you make, like, you can make like this, or like put two fingers up, and then when you shine a light on it, it'll create a shadow where it looks like a bunny hopping. Does that make sense? Have you all done that before? Okay, yeah, and some of you, yeah. If you've been in class with the projector last year, you may have, when your teacher turned it on, you might have made shadow puppets on the screen. Okay, so that's what you get to do today. And I've got two places where I want you to submit, okay? The first one is just the assignment. So that's gonna be in this top one. And in the second one, there is a Flipgrid. And what's exciting about the Flipgrid, before I've had galleries, but this Flipgrid is all of 4th grade at Lakeside will be putting their shadow puppet videos into Flipgrid. So once you put yours in there, I know you guys are first thing in the morning, but if you come back later on this afternoon, you can see all of the 4th graders' shadow puppets in there. Okay? Are there any questions? I don't see any hands. Okay. And social studies today, we have another Native American tribe that we're going to learn about. And this tribe is called the Lipan Apache. Okay. So you're going to use that same note sheet where you find the shelter, the tools they used, and where they lived. And the Lipan Apache, they are a branch of a larger group called the Apache. They were a great warrior tribe all over the United States, but we're just going to learn about the ones that lived in Texas. Okay, so you're just going to take some notes on them like yesterday, and then submit your notes in a discussion board. Okay. Are there any questions about anything? I know that's a lot of information. Sia, do you have a question?
I don't have a question, but I have like a fun fact.
Oh, cool. I love fun facts.
So did you know that if the sun was gone, we would know after 8 minutes, because the sun's light, it takes 8 minutes to get to us. And if you look at the sun, we're basically looking at the past.
Interesting. I like that fact. Thank you so much for sharing. All right, guys, so I have all of your folders open. You can go ahead and get your work done. I will be on here until 9:15. So if you have a question, come back. I want you guys to have a great weekend. Bye, friends that are leaving. Some of you can stay if you want to. Bye. Maz, you have a question?
Bye.
Bye, Anson.
What if you don't have a flashlight or something?
What if you don't have a flashlight? Then you could use a lamp. You could use
A lamp works.
What?
A lamp will work.
Yeah, a lamp will work.
Okay.
Yeah, a lamp will work. A light will work. You just might have to get, like, I can make a shape right here. I have a light above me, and I can see the shape, like the shadow down on this table below me. So you might have to get a little more creative with how you create your shadow puppets.
And I might need like my brother to hold like
Yeah, you might need, and I think your instructions say that you might need to find someone to help you, or you might need to set up your camera. Sia?
What if you don't want what if you don't want to share your Flipgrid to all 4th graders?
The Flipgrid is optional. You don't have to do it.
Okay.
Okay. But if you want to, at the very least, I would like for you to go and look at what other people did. Okay. Okay.